be able to solve the whole thing in this 1 hour. And other than this, if you have any particular questions from these topics that we are discussing today, do let me know and I'll be happy to help you out, okay? Any questions where you want to know how to solve the same questions on the GDC, then do let me know. I'll be happy to. Any questions anytime, I'm open. So what I thought was I'll start with the functions topic today, okay? Functions first, and then after that, we'll move on to trigonometry, geometry and trigonometry. So I hope that is okay for you guys. If you look at both these topics, functions is a topic where a lot of GDC is required. If you are good with GDC, major part of your questions can be answered with the help of GDC, whether it is solving simultaneous equations, not just solving to verify if you got the right answer or not, even sketching the graph, composite functions. How can you do composite functions on the GDC? Sketching the graph, finding the point of intersections, even solving the inequalities. All of these can be done with the help of GDC, okay? So I'm just going through these questions, and the questions what I've taken is from the past papers. They've either appeared in 2023, 22, so on. And these are from paper 4, where you can use your GDC. You can use your GDC for these kind of questions, and hence you should be okay. And yes, you can ask me like, oh, we can't just put this in the GDC and write the answer, and we will not get the full answer. Yes, you're right. For that, what I'm trying to show is that, of course, sketching and all you can do it with GDC, but once you've done solving, how you can also have an option to verify if you've done it correctly or not with the help of GDC. So let's look at question number 1, solving the simultaneous equations on using GDC. I'm guessing this is a very common questions, and I hope most of you are familiar with this. Let me show you how to do this with the GDC, okay? I hope all of you have access to your calculator. If I'm going fast, please put up a question or at least a message. So if you want me to repeat, I'll be happy to do so. So this is a calculator screen. You can do most of the things on the scratch pad, or you can just open a new document. The only things that you guys will be using for your exam is either a calculator or a graph, nothing else. Nothing else you would use, right, at this stage. Of course, when you go to higher classes, you will probably end up using a few more tabs. So let's add a calculator. So under calculator screen, menu is the option where you have all the operations. You have numbers, algebra, calculus, probability, statistics. All the options are right here. Since this is to do with the simultaneous equations, this is under algebra. Okay. So you have to click on menu, algebra, and solve system of linear equations. And we choose number of equations to be 2 variables, right? X and Y, because there are 2 unknowns in this. So we choose 2. So like that, you can also choose 3, 4, 5, depending on the unknowns, right? Click on OK, and then we write the whole equation there. So it is 5x minus 4y equals 13, and 3x plus 2y equals negative 1. 5x minus 4y equals 13. That's the first equation. I just type it like the equation, okay? And to type it now, you have the equation, the equal to symbol is right here. You can just use all these alphabet buttons to type out the equation, okay? So it's basically 5x plus or minus, 4y, then equal to symbol is right here. Next to the trig options, equal to 13. And similarly, click on the down arrow button. We go to the next equation and type the whole thing again. 3x plus 2y equals negative 1. Okay. And then click on enter, and you should be getting the solution for 1 and minus 2. Okay. 1 and minus 2 is your answers. So that's a very simple one, solving simultaneous equations. Now, let's move on to the next part. F of x is the composite function. G of f of x, again, a composite function. Now, how do we use GDC to solve all of these questions? Look, I understand that you might have to show a couple of working, but again, you can use this to cross-verify if you have got the right answer or not, and you will just probably just end up spending 1 or 2 minutes, not more than that, if you get really thorough with the calculator. Okay. Now, how do we do all the three questions using calculators is what I'm going to show you. Okay. So let's move on to the next question. F of x equals 3x plus 1 and g of x is 1 by 2x minus 3. So you can use your calculator as a computer where you save things and you can call again, you can work on it, right? So you can use that as a like a mini computer. Uh, Now, how do we write this expression in the calculator? F of x equals 3x plus 1 and g of x is equal to 1 by 2x minus 3. So you'll see that it's so probably you might some of you might be aware about it, some of you might not be. If you're not, then you'll see that how easy this is, and such a nice way. At least even if you do this, at least you end up getting 1 mark because of the right answer, right? Of course, working is required for all the questions. Now, how do we write this expression? How do we define this function? You got to click on menu, and you got to click on actions. Menu, actions. So when you click on actions, there's an option called as define. If you click on the define, you can define any functions there. So the name of the function is f. So use f only, right? F of x to bracket, okay? F, the brackets are right here. F of x equal to symbol 3x plus 1. So 3x plus 1. F of x is equal to 3x plus 1. Define. Enter. Done. You should be getting a message saying done, which means it's defined. So every time you call f, the function keeps coming up. You don't have to keep typing the same function again and again. Okay. So you define f of x as 3x plus 1. Next, g of x is 1 by 2x minus 3. Same way we define. So menu, actions, define g of x, right? G of left bracket and then x and then right bracket is equal to, now to put the rational, right, functions or anything which has a numerator and denominator, you can use this button right next to the number 9. There is a button which is next to a symbol like a book, which has all the symbols in it. Right? That is an option to write the rational function. So it's 1 in the numerator and denominator will be 2x minus 3. 1 divided by 2x minus 3, enter, and both the functions are saved. Okay, both the functions are saved. For the first answer, it's very easy, f of minus 2, right? Which means in the place of x, you're supposed to put -2, right? What you can do with the calculator is just, since you've defined f already, if you type f, it'll come in bold. It means that you're saved it somewhere. F of, open a bracket, -2, close a bracket, enter. So there you go. It gives you the value. It's telling you the answer was -2, which is the right answer. Okay. F of -2 is -5. Similarly, f of x. You can do it with the calculator. F of, open a bracket, again f of, in this case x, right? So they're not asking you for the expression. Probably, let's say they were asking a value, f of 2. Then you can get an answer, a value for it. F of 2. The answer will be like 22. Okay. But you'll see the next one, they have equated the composite function to 1 by 5. It's like you have to solve this. You have to find what g of f of x is and equate it to 1 by 5 and solve it. But how do you do it faster using the GDC? Now, to do this, there is an option called as numerical solve, NSolve. Hopefully, if you have attended the previous sessions, you might have seen what NSolve is. So to access that, you need to click on menu, algebra, and numerical solve. NSolve, okay? NSolve is for numerical solve. So basically, g of f of x equals 1 by 5. Exactly, we'll type it. G, open a bracket, f of x is equal to 1 by 5, right? So we'll type it as 1 by 5. 1 over 5. Oh, sorry, comma. You're missing out something, comma. Because with the variable we need to find is x, right? So comma x, okay? Close the bracket, comma x. Here we go. So the answer is 1. So you could have directly done this using Nsolve. So this is one way for you to verify if I've got the answer right or wrong. So g of f of x equals 1 over 5. Any questions? Do let me know. If not, I can just move on to the next topic. You can raise your hand or just let us know. Okay, right. So I hope this is clear. Is there anyone who wants me to show this again? Yeah, yes, we could. So next question. We found g of f of x. So now comes the sketching part. Now this is a major part in the question 4. Sorry, paper 4. That is, major chunk of marks is given to these kind of questions where you sketch, find the minimum point, maximum point, point of intersections, asymptotes, so on, right? Now, how do you do all of these questions on GDC is what I'll show you, okay? We are moving on to question number 2. Are we all good to go, guys? I hope we are fine. I hope I'm not going fast. Let me know if you want me to do any question again. Right. So question number 2, they have given us the expression which is x square plus 3x whole divided by x minus 2 times x plus 1. That is the uh, function. On the diagram, they're asked us to sketch the graph between the points x is minus 6 to 6. Okay. Now it's between minus 6 to 6. How do we sketch this? Let's just type in the function. To insert a graph window, this is a calculator window. This is where you can do all the calculations. To insert a graph window, click on Doc, click on Document, Insert the graph. So you can see the graph window. Okay. Doc, Document, the 4th option, and the 4th option. Doc 4. Okay. So now we type in the expression here. To type in the expression, again, since this is a rational function enumerated by the denominator, we'll choose a rational option. So it is x squared plus 3x, x squared plus 3x whole divided by x minus 2 into x plus 1. X squared plus 3x whole divided by x minus 2 into x plus 1. So this is your graph. Now, we need to fix the windows, right? Because they want us to graph between what? Minus 6 and plus 6. So the domain of the function is between negative 6 and positive 6. So click on menu. So we need to click on menu, Windows, okay? Because we have to change the window settings. So let's go to Windows settings, okay? To change the domain window, need to go to menu, Windows, and Windows settings. And X minimum is negative 6 and X maximum is 6. Click on OK. That's it. Now, this is your graph. So this is your graph. So you can directly copy down this into your paper. Look at the shape. I'll show you how to find the points as well, the x-intercepts. In fact, even the, the asymptotes. Asymptotes also, I can show you how to find it using the GDC. Done. So we're done with the sketching of the graph between the points minus 6. You see, plus 6 and minus 6. We have done with the graph. The next part is write down the equations of asymptotes. And if you notice it, there is two vertical asymptotes and there is one horizontal asymptote. Two vertical and one horizontal. Now, how do you identify which is the vertical asymptotes and which is the horizontal asymptote? Well, of course, for vertical asymptote, you'll just equate the denominator to 0. This is very easy. You will say x is equal to 2 or x equal to -1, x equal to -1 or x equal to 2. And horizontal asymptote can be tricky. Of course, horizontal asymptote from here, I can say it's 1. But how do we show it is 1? How do we show the horizontal asymptote is 1? Okay, to do that, there is another way to do it. That is, you need to click on menu. You need to click on menu, go to table, and choose split screen table. You can already see at 2, it's undefined. That's a vertical asymptote. Okay. At 2, it is undefined. And of course, even at -1 also it is undefined. Those are the two vertical asymptotes. You can identify what are the vertical asymptotes. X equals to -1 and x equals 2. Those are the two vertical asymptotes. But what about the horizontal asymptote? As x value is increasing, you see I'm going down and down. For what value is it going closer to? What is the y value approaching to? As I increase the value of x, I can keep going. The value of x is going closer and closer to 1. You never get the output as 1, but it goes very close to 1. Right? You can go as much high you want with x value, but it's going closer to 1. So therefore, you see from now, how do you remove the table? Okay, you're done identifying the vertical and the horizontal asymptote. Click on menu again, table, and remove table. It will remove the table. Okay. Menu, table, and remove table. So you can see as the x value is increasing, the horizontal asymptote also when it is decreasing too, the horizontal asymptote is approaching 1. So therefore, the vertical asymptote is x equals to 2 or x equal to -1. And the horizontal asymptote is y equals 1. Any questions? I know, I hope it is not too intense. I hope I'm not going fast again. I'm repeating. Let me know, guys. Please ask me questions. The whole point is that it should be useful for you guys, this session. Let me know if you want me to show this again.
So if anyone has any doubts, feel free to write in a chat box or they can raise their hand. So
Yes, of
feel free
course.
to
You
ask
can raise your hand and type in anything,
anything.
any
Chat
questions.
box, yeah, the chat box is open to all, and we all can see whatever the concern we have. And in case you
Right.
want sir to repeat the whatever has been done in last about this asymptote and all, you can please let us know.
I think we're good to go. I'll make it bigger if you want. Okay, I'm guessing they're fine. Okay, so asymptotes are done. Find the zeros of the graph. Zeros means either the x-intercept or the solutions of the graph. Those are different terms, they call it. Okay. Now, how do you identify the zeros of the graph from the GDC? So once you're done plotting, you can clearly see that there's one x-intercept here and there's one x-intercept here. Of course, you can tell it that 0 is its solution. Directly, you can tell. This also, of course, you can tell 1, 2, 3, 4, 5, 6. Okay, -6. But sometimes it might not be exactly integer here. Now, how do we do that? Menu. Click on menu. Analyze graph, that is. Then choose 0. See, analyze graph is a tool which you guys will be using. There are 4 things that you guys will be using: intersection, maximum point, minimum point, and 0. Okay, these 4 options you will be using a lot for these kind of questions in paper 4, and you will be able to find that in menu, analyze, and 0. So click on 0. Now choose the lower bound. Okay, this is my lower one. Click on it. Then move. There you go. -3, comma 0 is 1 point. Okay, it's -3. Each hint is a minus 0.5. I think that was 6. So -3 is one solution, and 0 is the other solution. So the x-intercepts are -3 and 0. Okay, -3 and 0 are your solutions. Analyze. If you want to see both the points, again, one of the things that you guys can do is you can always mark these points in the graph as well. So that might also add up some points to while you're sketching. Now, let's say this point is like, it's not clear. Like you saw what I did, it was something like this and it's not clear. You might think that that is 0.5 and all, you might make a note of a wrong point, which is not. It's not 0.5, it is 5. So let's say it was something like this, right? It's very easy to get confused like this. So what you can do is you can use this scroll. This is like a mouse in a scroll pad it is. You can use this to scroll. And when you come closer to the coordinates, a hand will appear. So if you keep holding that, like, you see that option that, hold it, right? Press and hold. It'll hold that, and then you can drag it and then release. Click on it again and release. Hold, drag, release. Okay, you can see the points. Okay. Similarly, on the same window, we can sketch on the same diagram. They want us to sketch g of x, which is x minus 3, and then solve for it. Look, you don't have to solve this algebraically. You just have to find the point of intersection. Where are they touching each other, right? Where are they intersecting each other? How do we do that? Click on tab. Now, if you have put in one graph, how do you put in more graph? Click on tab. You'll get an option to insert another graph, right? So which is x minus 3 in this case, x minus 3. Enter, there you go. That's the graph. Now, this is something that you should be able to graph it in your paper. Now, -3 is the y-intercept. 3 is the x-intercept. Join that, that becomes a straight line. Now, there's 3 points of intersections. Of course, if you solve this algebraically, it becomes very difficult. It might become a cubic equation, right? So once you sketch it, how do you find the point of intersection? Menu, analyze, intersection. Lower bound, click here. There you go. Minus 1.16. X values is what we need to write. That's one value. 1 is the next value, right? Minus 1.16 is one value. 1 is the next value. And there's one more value here. Click on menu, analyze, intersection. Again, lower bound and upper bound. 5.16 is another solution. Menu, analyze, intersection, lower bound and upper bound. So the first solution was minus 1.16, 5.56, 5.16, sorry, and 1. These are your 3 solutions. And you need to write down in the exam, use the graph to solve it. So what are you supposed to write? X equal to minus 1.16, x equal to 1, or x equal to 5.16. 3 solutions and 3 marks for it. Very easy marks. Okay. And the next part is again very tricky. You want to solve this inequality. You can't, algebraically, it becomes very difficult to solve it. For what values of x is g of x bigger than f of x? From the graph, you can identify that between this and this, these values are bigger, right? But between this point and the, what do you say, vertical asymptote, this graph is bigger. But again, beyond this, this graph becomes bigger. Again, beyond this, this graph is bigger. So you need to identify those. There are points, a chunk of intervals where the g of x, that is the red graph, is bigger than the blue graph. So this part is one of them, between 1 and -1. Sorry, 1 and what is the another vertical asymptote? 2, right? Yeah. So between 1 and 2, and anything greater than 5.16. Anything bigger than 5.16, again, the g of x is bigger than f of x. Here, the blue graph, that is f of x, is bigger than g of x. But here it is smaller than that. So there are two intervals. So the way you would write this in the exam is like this, between 1 and 2, and x is greater than 5.16. X is either greater than 1, lesser than 2, and x is greater than 5.16. These are it's an inequality, so there'll be infinite solutions. So this is how you would represent your solution for that question. Is there any other points where it is? There's also one more point. Can you tell me? There's also one more point where this is bigger. Maybe if anyone can put in the answer. There's one more interval where this values, that is g of x, is bigger. There's a small interval. A hint is it's again between one of the vertical asymptotes. Okay. All right. So the answer is actually between -1.16 and 1, -1. So x is greater than -1.16 and lesser than -1. Again, between this. So there are three intervals. This interval, and this interval is where, because there's a small part here, where this graph is bigger than this graph. Okay. So three intervals where the inequality works. Okay, so this is a part. I can look at this. I'm sorry if I missed it out. -6 to 6 is the domain, and the range is between 9 and -9. You could have also changed the range, but this range is between 6 and 6. Yeah, of course, you can change the y-axis too. Again, going back to menu, Windows settings. This is between -6 and 6. Use the tab button to move. Okay, tab, 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 tab. Okay, you can use your tab button to move down. So this is -9 and 9. Click on OK. That's it. This is your plan. So you can copy down the same thing to your paper. If no questions, I'll move on to the next questions. I think I'll do this. Huh? I'll do this because it's the same. Or I can do both. I can actually do both quickly. It's the same way. Because after this, I'll move on to trigonometry and geometry and trigonometry both. So now you know how to sketch the graph, right? You know how to sketch the graph. So you sketch the graph, and then you find either the maximum point, minimum point, or intersection points. Yeah, I can also show you one question where intersection I showed it you. I can also show you a question. Yeah, even this also I can show you how to use numerical solve to solve it. Yeah, maximum value, asymptotes, local maximum, local minimum. How do I identify? I can show you. Maybe this question I'll show it to you, and then I can come back to that. Okay. I'm doing question number 7. So I'll show you both asymptotes, maximum point, minimum point. And again, this is one more tricky questions where they want you to identify the values of k where it has exactly one solution. Now, how do you use your GDC to find that? And then lastly, Nsolve to solve all of these. So I'm doing question number 7. Please move on to page number 5, question number 7. Okay. Now, you might have made a complete mess of it. You can save this work if you want to, but don't insert a graph again. You can, as long as you know what you're doing, because whatever you're saved in the previous window might, like I told you, it's a computer, like a mini computer it is. So whatever your work is saved, it is saved. So you can keep calling it as many times you want. Like for example, the name of the function is f1 of x, right? I can call it here. And if I just type f1 of xe, I can put 3 and I'll get a value because that's a function that you've already saved before. So it keeps coming again and again. You don't have to type the whole thing again. So you can call it as many times you want. So that's how you save your time in the exam, that you type it once and then you call it as many times you want. Always start with a new document. If you're moving on to new questions, start with a new document. How do we do that? In your exam, so you see it's 1.1, 1.2, 1.3. That's how it comes in like a subsections of the questions. But then if you're moving on to new problem, second problem, then you can insert a new problem. I'll click on doc and you see click on insert. It's a new problem question. So it starts from again 2.1, 2.1, 2.2, 2.3, so on. Okay. So 2.1, I'm going to type in the equation that is x plus 5 divided by x minus 2 into x plus 3. X plus x minus 2 into x plus 3. Enter. You get this graph. The windows is between -5 to 5. So let's adjust according to that window. So menu, Windows settings, -5 to 5. Okay, so there you go. Do you notice that local minimum, local maximum point? So imagine this like a mountain, you have a maximum point here, right? Somewhere here, somewhere. And then you have a minimum point, a minimum value occurring at this somewhere here, right? So how do you identify those, or how do you find those maximum point and minimum point? First, asymptotes. I told you already how to find the asymptotes using the table. Using the table, you can find what asymptotes are. So click on menu, table, and split screen table. Menu, table, and so you can identify that 2 is, when it says undefined, it is not that value you cannot input into the function. That's what it means. The function is not defined for that x value. So x equals to 2 is one vertical asymptote. And if you go up, x equal to -3 is also one more vertical asymptote. Okay, x equal to 2 and x equal to -3 are the two vertical asymptotes. And how do you remove the table back? Menu, table, remove table, and the table will vanish. Okay. Yeah, there is no, you can probably clearly see that it's the vertical asymptote is not, but there's something called as oblique asymptote, which is not there for your level. So you don't have to worry. You only need to write down the equations of asymptote. That's why they clearly told you parallel to y-axis, which is nothing but vertical asymptote. You don't have to find anything else. Now, how do you identify the maximum point and minimum point? Menu, analyze, third option, maximum point. Lower bound and upper bound. There you go. That's the maximum coordinate. So x is 1.03. Minimum value, menu. Identify where do you think the minimum, well, of course, from the graph, you can look at it and tell. But to find the exact value, use the scale it down between that. Menu, analyze, minimum, lower bound, and upper bound. There you go. See, suddenly appears. See, it says this can be the minimum, but then we already know this is the minimum. There's nothing more minimum than this. So that's 2.99 and 3.83. So maximum value occurs at 1.03 and the minimum value occurs at 2.99. Any questions? Let me know. Okay, so maximum point and minimum points are done. Next. So we're done with local maximum, local minimum. They want you to write the coordinates. So you can just write those two coordinates that you found. The next part is write down the range of k values, which has exactly one solution. Okay. Do you notice that when you draw horizontal lines, like for example, if you draw a horizontal line, let's say -5. So this horizontal line will be touching the graph at 2 points, which means that two solutions. If you draw horizontal lines here, you'll probably see that three solutions the line will be cutting through. Even here also there might be three solutions or two solutions. But then between 2 points, when you draw horizontal lines, it's cutting the graph at exactly 1 point, and that's exactly one solution. Now, between what 2 points are there exactly one solution? And that is a link to the previous part, that is maximum and minimum. Maximum point and between minimum point, if you draw vertical horizontal lines like this, it'll be cutting the graph at exactly 1 point, which is exactly one solution. So k, what are the values of k? So k should be greater than 1.03 and lesser than 2.99. So you'll say k is greater than 1.03 and lesser than 2.99. For any of these k values, let's say you put k as 2, for example, 2. So look at that. It's only touching the graph at exactly 1 point, only one solution. Okay? Anything between that, you're totally fine. If that's your answer. This is how you identify. Similarly, if they have asked you how many points is exactly two solutions or three solutions, then accordingly, you can see how many times is it touching the graph. If it's touching 2 times in a graph, then two solutions. If it is touching 3 different points, then 3 solutions. Okay, like that you can identify different intervals where it satisfies the given condition. Okay. Now, finally, how do you solve this inequality? -4, -x. We just put in the insert the graph, right? So let's insert the graph. Tab minus 4 minus x, right? -4 minus x. So, look, if you want to, you have written something and you want to remove it. No, just I can use the scroll button. Go there. You can use the shift and click on it. It will give an option to delete. You can delete it. You can delete the graph, right? You can, like I said, there's so many things that you guys can do. Delete it. I will not see the line. I can delete it. Right? Now, this is the equation that we have written. -4 minus x. You can clearly see that there are 3 points. 1, 2, and 3. 3 points, right? So how do you find that? Point of intersection. Menu, analyze, intersection. Low bound. So -3.35 is one solution. -1.52 is the second solution. And 1.87 is the third solution. So you got 3 different solutions where f of x graph is equal to g of x graph. This point, and this point. I hope I'm clear. And then, of course, inequality. I told you f of x is greater than g of x. Very clearly seen, you know. That's why they asked you to find the point of intersection. Menu, analyze, intersection. That's one point. And this is the other point. Okay. Done. Now, when x is greater than 3.35, sorry, -3.35, you see the blue graph is bigger than the pink one, or f of x is greater than the g of x. But lesser than that, this graph is bigger than that. You can clearly identify it from the graph. right? So x is greater than minus 3.35, but less than minus 3. So one solution, the way you would write the solution is, it's an inequality. X is greater than minus 3.35 and less than minus 3. That's one set of solution. Again, between this point and this point, it is greater. So it's between minus 1.52 and 1.87. X is greater than 1.52, minus 1.52, and x is less than 1.87. That's the next set of solution. Again, x is greater than, next asymptote is 2, so x is greater than 2. So like that, you can represent the answer in the inequality form. So these are your solutions for x for inequality. I hope I'm clear. I think I can't solve any more questions on functions. I think I'm running out of time. But you can take that worksheet and you can try it on your own to practice more questions from functions using GDC. So that is to do with functions. Let's move on to now geometry and trigonometry. See, not much of GDC is used for this, of course, as much as you intensively use for functions. You use it in a much more lesser way. But as you go to higher classes, you'll see that there's more applications of trigonometry and geometry, and you can use a GDC to solve those questions. Now, all the trigonometry options or geometry options also, I'm going to start with a new window or a new problem, like I told you. So it's a 2.1. Doc, insert, new problem, and add a calculator. So you see it starts from 3.1. Now you can ask me like, so you are opening so many windows. Isn't it very difficult for me to see if I want to go back and see my questions later to verify my answers? You can. All you have to do is click on Control and click on the up arrow button, and you'll see all the problem 1, problem 2, everything coming up here, and you can go navigate between different questions, and you can go back to the respective questions later to verify your answers. Okay, so this is one quick way to keep your work there and then later come back and just check your answers. So you don't delete everything. Huh? So 3.1, let's start with another question now. So the question is, calculate the length of BD. Right? They have given us the length of DC, which is 15, and the angle is 41 degree. It's a right angle triangle, clearly given it's 90 degree. So the trigonometry ratio that we might end up using is, because BD is a side opposite to the angle 41 and hypotenuse is given, the trigonometric ratio that we would use is sine. Right? So we would write sine 41 degrees is equal to opposite side by the hypotenuse. That is, the opposite side to the angle is BD and the hypotenuse is DC. So BD is BD, we don't know the value. DC is 15. So therefore, BD is equal to 15 times sine of 41 degrees. Now, how do you find these values using GDC? Well, make sure your calculator is in degree mode. Okay. Sometimes it can be. There's another way of measuring the angles called as radian mode. If you just click on it, it changes to RAD, which is radian mode. And click on it again, it changes to degree mode. Make sure your questions are in degree mode. The calculator is in degree mode. The answer is 15 times sine 40. So 15 into trigonometry options can be found from this. There's a trig button there. Click on trig, and you'll see all sine, cost, and everything up here there. Sine of 41. Enter. So your answer is 9.84. Okay. So 9.84 is your answer. So the length of BD is 9.84. And of course, they want us to find the area of the triangle ACD. Now, you know, it's a half into base into height. Height is the BD, what we found. And half 17. So answer is half into, that is 0.5 into the base is 17 into the previous answer, which is 9.84. Look, if you have a big answer and it's very difficult to type out the whole thing and might take a little time to type out, what you can do is you can use your up arrow button go to that answer which you selected and click on enter. It just automatically copies down. Enter. And that's your area of triangle. So that way you can copy down your answer. It doesn't matter. It need not be in the previous step. You can also go to maybe 5 steps before, 6 steps before. You want to copy one answer from 6th or 7th step back to what you're doing now. You just go select that and click on enter, and you can select that uh, uh, value and then start working on it. Okay, so that's your area. The last part is, again, this is the trigonometric functions, which involves modulus. This is again involving graph, and it was coming up in trigonometry and geometry. I thought I'll just try to work on this as well quickly. Sort of I can continue, right? I hope there's no question time or something, because I don't think students are. Any questions, students, until now? Because I know it's only 10 minutes. If you have any questions that you're trying to solve in the exam, or you have some worksheets and you want to ask me, you can please go ahead and ask me. If there's any question that you're wondering how to solve that using GDC.
Yeah, if you have any questions, any queries, because we are almost done with, I guess, all the questions. Like till here, if you have any questions, anything you want to ask, please you feel free to write in a chat box, or you can raise your hand. And if there's anything in specific you want to ask with regards to the topic which we are discussing today, please feel free to write it in a chat box.
Okay, so I'll just show you, because I know it was a tricky question. I really wanted to do this. This modulus, how do you access modulus using the GDC? Okay. Let's insert a new problem again. Doc, insert a problem. So you see 4.1. Let's add a graph. You can also do it in the calculator. Okay. How do you plot that, and how do you choose the modulus function? Now, to choose the modulus function, again, the button next to the 9, you see that modulus operator is there. Click on it. And this is the option. Okay. So that button, and this is the option to choose the modulus operator. Okay. Now, the function is 2 cos, 2 times of cos, trig cos, x minus 45, x minus 45, come out of the modulus function, minus 1. Again, make sure the calculator is in degree mode, okay? Degree. If it is degree, the whole thing goes wrong. Make sure your calculator is in degree mode. Note, disclaimer. Close the bracket. Enter. And it is between minus 90 to 90, right? So again, change the windows. Menu, Windows, settings, minus 90 to 90. Okay, there you go. See, sometimes I understand that graph might not be the exact shape what you want. So you fix the windows. To fit it according to your windows, there's an option to do that. So click on menu, Windows, and Windows Zoom Fit. So it will fit according to your window scale. So that way it becomes a little more clear for you to see. Now we know how to find the maximum point. There's a maximum point, of course. Write the x coordinate where the curve meets the x-axis. You see 1, 2. There are 2 points where it meets. You already know how to do it. Menu, analyze, maximum. Lower bound, upper bound. That's 1 point. Menu, analyze, 0. Lower bound, upper bound. So that is sorry, this is not a point. I choose maximum. Sorry. So menu, analyze, 0. So minus 75 and minus 15 degrees are your 2 solutions. The x-intercepts. And now how do you find the maximum point? Menu, analyze, maximum point. Lower bound, upper bound. So there you go. That's the maximum point. Okay. So these are the ways you can identify these points. And of course, now you know how to do it, right? The next part, line intersects the graph, which means click on tab, right? When you click on tab, you insert a new function and then 0.005x, 0.005x, enter. You see there's one point of intersection, second point of intersection, third point of intersection. Find the point of intersection. How do you solve the inequality? Same way, I've already showed it to you. Where this graph, the first graph is bigger than the other one. So this is one part. From here to here is another part. That is the part where this graph is bigger and this graph is bigger than the red one. So you already know how to find the point of intersection. Menu, analyze, intersection, right? That is one point. That's another point. And the last point is, that's another. So your answer will be x is less than minus 64.8. X is between minus 17.1 to 88.8. That is your answer for that inequality. Now you see, we have all the working we have done is in the different tabs. Of course, you can click on this and you can scroll down to whichever tab you want, or like I told you earlier, control and up arrow button, you can navigate between different problems that we have done. So in your exam, you can always save this and then you can check, okay, I've done this, and okay, now I want to verify this. Maybe at the end of the exam when you're done, if you want to review your answers, you can do this. I hope you guys have learned something from this session. If there's any, I don't know, if you guys didn't ask any questions, which means either I've done a good job or you guys have not followed it, right?
Right. So
it can be one of them, I guess. So,
no, I'm sure they would have learned a lot from this session, because that was very, contentful session you have delivered to us, and there is a lot of things you have shared actually. So if anyone has any doubts, please, we have like very few minutes left. So if you have any doubt, anything you want to ask on any specific question which sir has solved today, or on anything you already have on functions and geometry, if you want to share something, if you want to request him to show something, repeat something again.
Yeah, it's okay. I don't mind extending another few minutes. It's okay.
So, please, it is possible we can extend the session for next 5-10 minutes, 15 minutes, but only when like you have anything to share, please feel free to write in the chat box. Raise your hand.
Yeah.
Yes.
Okay, but I'm happy that some of the students on Saturday they came and joined. So good. If there's no questions, I think I feel we can stop, right?
So if you don't mind, I have one question.
Yeah.
So will it be possible if we can generate the equation of asymptote? Though we could find the asymptote points from that equation, like x minus 2, x minus 3, this is quite like easily feasible. What are the asymptote points? At what point it is the asymptote? X equals to this, because the denominator is going to for the infinity. So we can find at what value the y is going to infinity, so we can get the value of x. So if we want to generate the asymptote equation, can we do it? That is one thing I was like also trying to check.
Actually, see, table is one of the ways. I showed you, right? From the table only, you can identify that it's undefined at those values. X equal to 2 and x equal to minus 3 is undefined. So directly you'll get it from there.
Okay.
I showed it to you, right? So menu, table, and split screen table. So at x equal to 2, see, x equal to 2 is undefined. And then when you scroll top also, you can see that x equal to minus 3 is undefined. So those are your two vertical asymptotes.
Right. Got it.
Yeah, otherwise it becomes too easy. If you type in a function directly, it tells you the asymptotes and all. That becomes too easy in exam point of view. I think little bit of research of putting the table and identify, this value is undefined. That should be there. Or another way, like you said, Saurabh, another way is using the calculator. Let's say this is the function. You only take the denominator function. Now, denominator function, for what values of x will the denominator become 0? For only those values, it is vertical asymptote, right?
Right. We can equate to
So-
denominator equals to 0, then we'll get the
Correct.
actual points.
Correct. So
Okay.
algebra, numerical solve. So x minus 2, x plus 3, right? So x minus 2 into x plus 3 equal to 0, comma x. You're getting only one solution, but there's one more solution. And there is a condition operator for that, right? So this is a solution where x is greater than 0. So when x is less than 0, what are the solutions? There's an option, there's a condition operator, like in probability, right? So control equal to a condition operator, x is less than 0.
Less than 0, correct.
So x equal to 2 or x equal to minus 3 are your solution. So this is another way to do it.
Done.
Or of course, you can also use polynomial tools, but for that they might have to expand and all. Yeah, so many ways to do it.
But I guess polynomial won't be the part of the IGCSE thing. So
yeah,
it
it
is
won't
what
be. So exactly. I think Nsolve might be enough, right?
it is a part of, yes, because
Yeah.
I guess we don't have any questions from the attendees for now, so maybe we can wind up the session.
Thank
And
you. Thank you, Saurabh.
Before we wind up, I would like to thank Rohan
Oh,
sir.
wait. We have a chat.
That thank you so much for
Yeah.
being here
So
Saturday
both
afternoon.
Nsolve and polynomial tools. Yeah. Polynomial tools are. It is there.
They're part of. Okay,
I remember. That's what I was wondering.
Right,
You're right. Thank you, man.
Thank you, sir. Thank you.
It's been long, by the way. I'm teaching IGCSE. I taught in 2016, so I have not taught IGCSE until now. Right. Okay. So, and one more question.
No, he's saying yes, Rohan sir.
Okay. All right.
So, thank you so much.
Welcome, man. Welcome.
Yeah. Thank you so much, sir, for being here on Saturday afternoon. I'm so thankful that it was a great session, very, very contentful session, and you have shared your knowledge and the expertise on the calculator.
My pleasure, sir.
I'm sure the attendees would have learned a lot. Even I have learned a lot because I was able to share my queries also because of this. So thank you so much for this session. I'm sure it is very, very much helpful, and it's gonna be going to help many who are going to follow the recordings and who are gonna follow the same. I'm sure. Thank you so much.
Thank you very much. Thank you for organizing.
Thank you so much, sir. Bye.